Hello everyone. The title of this video is Writing Equations of Parabolas in Standard Form. Alright, so in this video I'm going to be going over examples that are taken directly from a free online textbook at openstacks.org, and I'm in their Algebra and Trigonometry text, section 12.3, called the Parabola, and I'm under the heading Writing Equations of Parabolas in Standard Form. Each example I do will either be an example from the reading or one of the try it problems from the reading or one of the exercises at the end of the section that's related to this particular objective. Alright, so before I get into some of my examples, I'm going to tell you right now that I am going to be assuming that you've seen my videos on graphing parabolas with vertices at the origin and graphing parabolas with vertices not at the origin, or have read through some other parts of this section. But we're going to be looking at writing an equation of a parabola in one of these two forms here. Okay. Either y minus k squared equals 4p times the quantity x minus h, or x minus h squared equals 4p times the quantity y minus k. All right. And in these forms, the vertex of the parabola is at the point hk, and the value of p, right, you see this 4p here, the value of p tells you where the focus is going to be. All right, now if it's y squared and x is not, if y is squared and x is not, the focus will either be to the right or left of the vertex. The axis of symmetry for the parabola will be horizontal. If it's x minus h squared and then y to the first power, x is squared, y is not, then the focus will either be above or below the vertex, and the axis of symmetry for that parabola will be vertical. And again, they have like a little box here with all these pictures of different scenarios for different kinds of parabolas you might see: opening left, opening right, opening up, opening down, right? But like I said, I've already done a couple videos on graphing them. Now, in these examples I'm going to do here, we're going to be given information. We're going to be given information about a parabola, its focus, and its directrix. Right? All the examples I have in today's video, again, taken from this textbook here. I'm going to be either given the focus and directrix or some graph of a parabola and asked to write the equation in standard form. So let's get started. So just again, writing equations of parabolas in standard form. And I'll also draw them as we go. Right. So first example, I'm given the focus of the parabola and the directrix. Now remember, this is a special point and special line that define the parabola, right? Every point on the parabola will be the same distance from this point, the focus, and this line, the directrix. Alright, so if I draw this stuff in, I'll start making a rough sketch of all the information I gather on an XY plane here. So say here's negative 1/2 on the x-axis, comma 0, right? This is the focus of the parabola, and the directrix they're telling us is a vertical line, x equals 1/2, right, which is over here. And a vertical line, right, x equals 1/2, there's the directrix. All right, so right away I can tell you what the axis of symmetry is going to be. All right, the axis of symmetry is perpendicular to the directrix and contains the focus and vertex on it. So it looks like the axis of symmetry has to be the x-axis here. All right, now in the future I'm going to abbreviate axis of symmetry, like in other videos, as AOS. is y equals 0, right, the x-axis. And because the axis of symmetry is horizontal, because the axis of symmetry is horizontal, the equation we're going to need to write is this. You're going to have y squared and not x. Some quantity with y minus k squared equals 4 times p times the quantity with x minus h. Where again, the vertex is hk. Right, so if we know the vertex of this parabola, we know the h and the k, and then we just need to know how to get from the vertex to the focus, and that'll tell me the value of p. I need to find h, k, and p here. Well, the vertex should be easy enough. Remember, the vertex is exactly halfway between, on the axis of symmetry, the focus and directrix. So that would be the origin here. There's the vertex. It has to be the origin. So the vertex is the origin, 0, 0. So if I put those in, we got y minus 0, which nobody writes y minus 0. That'll just be y squared on the left equals 4 times p times, and then, again, you can put the quantity x minus 0, but usually that's just written as x. So now the equation looks like this. And now I just need to find p. Remember that the value of p is just telling you how far and in what direction the focus is from the vertex. And you see how the focus here is half a unit to the left of the vertex. So p is equal to negative 1/2. If it were to the right of the vertex, going to the right is a positive change horizontally, p would be positive 1/2. But from the vertex to the focus, p is negative 1/2. It's going to the left horizontally is a negative change. So I just pop that in here. And we get y squared equals 4 times negative 1/2 times x. Or, when you simplify this, y squared equals 4 times negative half is negative 2 times x. And here we go. There's the equation of the parabola they're describing in standard form. Now I can just find some other points. The 4p is negative 2. And remember the length of the lattice rectum was the absolute value of 4p, again from earlier videos or other reading from this section you've done, I'm assuming. So if I just go up from the focus 1 unit and down 1 unit, I'll have other points on the parabola. So here's negative 1/2, 1, and negative 1/2, negative 1. And once you have the vertex and a couple points on either side of the axis of symmetry, you can draw a rough sketch of the parabola, right? The parabola will be something opening like this, opening to the left. And that's it. That's all we're asked to do. I didn't have to draw it. We're just asked to write the equation for such a parabola in standard form. Right, so y squared equals negative 2x. That would have a focus at negative 1/2, 0, and a directrix of x equals 1/2, right, and vertex at the origin and all that stuff. Right. Great. All right, the same thing for the first several examples. Example 2, I'm once again given a focus and directrix. Right. So the focus, and again I'll make a little drawing over here. The focus is at the point 0, 7/2, right? So let's say that's 7/2 on the y-axis. There's There's the focus. And the directrix is a horizontal line, y equals -7/2. So it looks like, once again, based on where the focus and directrix are, that the vertex is at the origin. That's exactly halfway between those on the axis of symmetry, right? The axis of symmetry would be the y-axis. Right? The axis of symmetry would be x equals 0, that line. Here's the directrix. So yeah, so the vertex has to be the origin again. Right? It's the point that's on the axis of symmetry, exactly halfway between the focus and the directrix. So vertex, again, that was the h and k. That's 0, 0. And the axis of symmetry is vertical. So we have an equation that's going to look like this. X squared equals 4 times p times y, right? Because again, the h and k are both 0, so I don't need to put x minus h squared and y minus k. Right? It's just x and y. So now I just need to find this p, and that comes from, how do I get from the vertex to the focus? And when you're going vertically, going up is positive, going down is negative. From the vertex to the focus is up 7/2 units. Right, so p equals positive 7/2. So we pop that in. X squared equals 4 times 7/2 times y, and then simplify this. The equation for the parabola being described to us is x equals 14, x squared equals 14y. Alright, and then again, cut this 14 in half, 7, go right 7, left 7, get that lattice rectum. Here's 7 left, 7 right. And we get some other points on the parabola, right? 7, 7/2, -7, 7/2. These are solutions to this equation. And once I have those points at the ends of the lattice rectum in, I can draw a rough sketch of the parabola. That first thing I drew is pretty crappy, sorry. There's this parabola opening up with a vertex at the origin, focus at 0, 7/2, directrix at y equals -7/2. And something I forgot to mention in the first example, I'm sorry, but the reason why, if you're given just a focus and a directrix, you can define a parabola, is because of, how a parabola is defined. A parabola, all the points on the parabola, you could take any point you want, any point on this curve, any solution to this equation. If you were to take the distance to the focus and then the distance straight to the directrix, go perpendicular to it, those distances will be equal, no matter where you're at on the parabola. Go take any point, go to the focus, go to the directrix, and those are the same lengths, no matter what point you're at. That's why the focus and directrix help us, to write the equation for our parabola pretty easily. All right, but again, they didn't want the graph or anything, they just wanted the equation in standard form. All right. All right, so far, we've seen examples where the vertex was at the origin. Hopefully that doesn't continue. And I don't think it will here. So once again, given the focus of the parabola and the directrix. This time the directrix is a vertical line, right? X equals -7/2. So let's just draw it in. Very rough sketch over here. So -1/2 for x and +3 for y. Again, I'm not doing like graph paper or drawing to scale or anything. So if you want to use graph paper, that's cool. Here is the focus, and the directrix is given to us as x equals -7/2. Now -7/2 on the x-axis would be over here somewhere, right, to the left of -1/2. And it's a vertical line, right? X equals a number is a vertical line. So there's the directrix that was given to us. All right, so it's very clear that the vertex will not be the origin. But I can tell you right now what the axis of symmetry is. The axis of symmetry is this line here, right? It's a horizontal axis of symmetry, and it's y equals 3, right? Just the y coordinate of the focus. All right, so the vertex, again, is going to be halfway between the focus and the directrix on the axis of symmetry. There's the vertex, and the coordinates of the vertex, right? You just do some averages here. You just say, hey, what's halfway between negative 1 half and negative 7 halves? Well, that's a distance of negative 6 halves, right? It's a distance of 3, so 1.5 in between. So negative half minus 1.5 would be negative 2. So this is the point. The vertex is at negative 2, 3. All right. And there's your H and K. Now, because the axis of symmetry is horizontal, we're filling in this equation. Y minus k squared equals 4p times x minus h. Now if I put in negative 2 for h and positive 3 for k, now we're looking at this equation. Y minus 3 squared equals 4p times the quantity x plus 2. Because minus negative 2 would be plus 2. And now all I need is the value of p. And I fill that in and simplify, and we'll have our equation for the parabola described to us in standard form. And again, you just think about, how do I get from the vertex to the focus? That's moving to the right. That's a positive change horizontally. So the value of p is going to be positive. And what's the distance from, negative 2 to negative half? Well, that's negative 3. That's positive 3 halves, right? I went to the right 3 halves. From negative 4 halves to negative 1 half. That's right 3 halves, positive 3 halves. So I pop that in. Got y minus 3 squared equals now 4 times 3 halves would be 6 times the quantity x plus 2. And this is the equation of the parabola being described to us in standard form. Now if you wanted to draw the rest, the value of 6, the value of 4p, absolute value of 4p, that's the length of the lattice rectum. Cut that in half, that's 3, and then you go from the focus up 3, down 3 here. So up 3 to 6, down 3 to 0 there, and so from the focus up 3, there's a point on the parabola, negative 1 half 6, and then down 3, you'd be at negative 1 half 0. And those should be points on the parabola. And now that I have the vertex and a point on either side of the axis of symmetry, I can draw a rough sketch of the parabola. Right, this parabola opening to the right like that. Okay, but again, all they wanted was this equation. You don't even have to do drawings. All right, and I'll show you. In fact, I will even show you with the last one that I don't need to make a drawing. This isn't the last example, but it's the last one where I'm given just the focus and directrix. All right, so here, the focus of the parabola, 1/1/3. The directrix, y equals 11/3. Now the directrix is a horizontal line. That means the axis of symmetry will be vertical. Right? And if the axis of symmetry is vertical, then the equation we're writing has x squared and not y. It's going to be that version of the standard form where it's x minus h squared equals 4p times the quantity y minus k. Alright, so if I'm going vertical axis of symmetry, so look at the y coordinate of focus and then 11/3. What's halfway between 1/3 and 11/3? Well, add them up, that's 12/3, that's 4. Divide that by 2, that's 2. Halfway between these is positive 2. So the vertex is at the point 1, 2. And there's your h and k. And so now we're looking at the equation x minus 1 squared equals 4p times y minus 2. And now I find P, and then you gotta think, well, to go from 1, 2 to 1, 1/3, 2 is higher than 1/3, so you'd be going down. The value of P would be a negative 5/3. Right, because 2 is 6/3, I'd have to go down 5/3 to get to 1/3. And I pop this in, and we get the final equation, x minus 1 squared. Now 4 times negative 5/3 would be negative 20/3, and then times the quantity y minus 2. And here's the equation for that parabola in standard form. And as I was saying, if you know what you're talking about here, you don't need to draw a picture. But a picture never hurts. I mean, I'll still draw it now. All right, I'll draw it now and go through the process again. So again, the focus was at 1 and then 1/3. All right, that's the focus. The directrix y equals 11/3, which is above 1/3 on the y-axis, and that's a horizontal line. There's the directrix. And if that's the directrix, right, the axis of symmetry will be a vertical line going through the focus here. The axis of symmetry would be the line x equals 1. And like I said, the vertex is going to be halfway between the focus and the directrix. And the average of 11/3 and 1/3, as I said, is 2. All right, so the vertex is the point 1, 2. And then from the vertex to the focus, you have to go down, which is a negative change, so the value of P is going to be negative. And like I said, that's from 6/3 to 1/3, that's 5/3 down. Right? And I got P equals negative 5/3, and I pop that in. All right. Now, if you wanted some other points on the parabola, take 20/3 here, the absolute value of 4P, cut that in half, that's 10/3. And I go right and left from the focus 10/3. Now 1 is 3/3, so if I go right 10/3, that's 13/3. If I go left 10/3, that's negative 7/3. And I get a couple points on the parabola. There's 13/3, 1/3, and negative 7/3, 1/3, and then I can draw the parabola. And again, a very, very rough sketch. This is actually a very terrible drawing, but rough sketch of this parabola opening down. And I'll leave it to you to check that 13/3, 1/3, and negative 7/3, 1/3 are actually solutions of this equation here. They should be. All right. Now my last two examples will be a little different than these. We're going to be given a graph of a parabola, and it just asks to write the equation of that graph, in standard form. All right, so my next example, example 5, is exercise 52 from the text. So we go back to the text here, scroll down to the bottom of the section. I'd highly recommend reading this solving applied problems involving parabolas as well. It's very interesting, but not doing that here. 52 is, like I said, it says determine the equation for the parabola from its graph. So look at this. I mean, I'll draw a very rough picture of what they have here. So they're giving us the vertex is at 3, 2. They're telling us that's the vertex. The axis of symmetry is a horizontal line. Axis of symmetry, AOS. The focus is at negative 1, 2. And so there's the focus. And the parabola is, just this parabola opening left. And they don't give us any other points at all. So it's like that. It should be symmetrical about the axis of symmetry, right? Now, 2, 3 is the focus. So that's the H and K. And since the axis of symmetry is horizontal, the y will be squared and not the x. So it's going to be that form y minus k squared equals 4p times the quantity x minus h. and I know h and k are 2 and 3, so I put 2 here for h, 3 here for k. So now using the vertex, we have y minus 3 squared equals 4p times the quantity x minus 2. And then the value of p is, how do you get from the vertex to the focus? Now notice I'm going left, so the value of p is going to be negative. That's a negative change when you're talking horizontal. And then from 3 to negative 1, that's 4 units. So this is negative 4. I went left 4. So the value of p is negative 4. And I pop that in, and we get the final equation, y minus 3 squared equals 4 times negative 4 is negative 16 times the quantity x minus 2. Right. And that should be good. Right. Now if you want to check it out, we can put this equation that we just wrote here into the Desmos website. Free online graphing calculator at desmos.com. And I'll enter the equation I just wrote. Y minus 3 squared equals negative 16 times the quantity x minus 2. And if you can see the point 2, 3 is the vertex. And if you zoom out far enough, it might come to a point where it looks like it's opening left. I mean, I don't know. There are no other points labeled here. So just at first glance, I'm saying, yeah, this graph looks like that graph, and it has the same vertex. So there's a good chance that my equation's right. But without other points, I couldn't tell for certain. But I know based on my previous exercises that I'm doing all right here. This is good. Okay. All right, and then I have one final example, just like this, where we're given a graph and asked to write the equation for the parabola in standard form. All right, so my last example, example 6, is exercise 54. Right, so back to the textbook here. Again, the even numbered ones you can click on the links and it'll take you to the solutions. So I'm not doing those. All right, so here's 54. And once again, we're only given the vertex and the focus. But that should be enough to write the equation. So again, I'll draw a very rough picture of what they have there. All right, so the vertex is at negative 3, 5. So there's negative 3, 5. That's the vertex. So there's the h and k. Then the focus, and the axis of symmetry is vertical. There's the axis of symmetry. The focus is below the vertex, and this is at negative 3 and then positive 319/64. There's the focus, and then the parabola is of course opening. It always opens around the focus, right? Opening down like this. Again, a very rough sketch of what they had. All right, so the vertex, like I said, is the point negative 3, 5. There's your h and k. Now this time though, the axis of symmetry is vertical, right? The parabola is opening up or down here. So the equation I want to write will have x squared and not y. It's going to be this form, x minus h squared equals 4p times the quantity y minus k. All right, so I know h is negative 3, k is 5. We're looking at this equation. X plus 3 squared equals 4p times y minus 5. And now I just need to find p. And once again, it's easy to do. Just you have the vertex and you have the focus. Now you see how from the vertex to the focus I'm going down. That's a negative change. So the value of p is going to be negative. And we just need to know the difference between these two things, 5 and 319/64. Now 5, when you get a common denominator, multiply by 64 over 64, that'd be 320/64. All right, 5 times 64 would be 320. So the difference here is only 1/64, but it's down, right? So the value of p is negative 1/64. for this particular parabola. And when I put that in for p, we get the following and final equation here: x plus 3 squared, and then 4 times negative 1/64. Well, 4 goes into 64 16 times, so this would be negative 1/16 times the quantity y minus 5. And there we go. That's what they want. The equation of the parabola shown to us in standard form. The quantity x plus 3 squared equals negative 1/16 times the quantity y minus 5. And I'll leave it to you. You can enter this into the Desmos site and see that it's a parabola with a vertex at negative 3, 5 and opening down. And that's about all you're going to be able to compare it to. But it should be good. All right, and that's all I've got. And my hope is that watching me do these 6 examples here helps you in some way when you're asked to write an equation for a parabola in standard form on your own, right, given certain information. And thank you very much for watching.